Next, we will hear from Laurence Willemet.
Have you ever wondered what would be your life without your sense of touch? You probably all have experienced getting back home on a cold winter night and struggling to insert your key inside your lock. When your fingers are numb because of the cold, the mechanoreceptors buried inside your skin layers have some trouble sending tactile signals back to the brain, which can make even the easiest task a real challenge. With the emergence of teleoperation, where a remote operator is performing a task through a robotic arm, the human is deprived of their sense of touch and is generally feeling as frustrated as you when trying to open your door. In the case of a robotic-assisted surgery, for example, most of the surgeons are complaining about the lack of realism of the tactile rendering. Enabling a true remote touch will help them to feel not only the softness of an organ, but also if there is a more rigid body, like a tumor, inside this organ. So my goal is to find a way to transmit the tactile information directly to the hand of a remote operator in real time. And to do that, I am using a tactile sensor called a gel site that function in a similar way as the human skin. When we interact with objects, our skin is deforming, and the tactile information is contained in this deformation. And the tactile sensor is sensitive to the same kind of deformation. However, we cannot send the output of the sensor directly to the user because the data stream would be too large to be useful in real time. So here the challenge is we need a tactile format of encoding. And to achieve this challenge, I am taking inspiration from other modalities, like vision or audition. The methods are called perceptual coding strategies due to their ability to compress the information that is beyond the human perception. This is, for example, how the MP3 or MP4 format emerged for audio and video format. If we can find a dictionary of skin deformation able to encode all of the tactile features, like softness, shape, friction, or textures, then we will be able to bridge touch over a distance, which can be 10,000 of kilometers. Having a display that provides feedback from a remote site will help the user to feel the tactile properties of a remote site. They will rely on their sense of touch, which will reduce their cognitive load. So then they will be able to work faster, which will reduce the duration of the surgery. So maybe in 10 years from now, with remote touch, the surgeons won't have the feeling that they are performing surgery outdoors in the New England winter anymore.